So I guess we can probably get started.
Sorry, I wasn't looking at the time, Joe.
No,
I
it's
went
fine.
off on a tangent.
It's fine. We've got my talk scheduled to start in 1 minute. The only don't really have any housekeeping issues here. Just welcome to day 3 of our workshops with the focus on engineering solutions. And I'm going to give a talk that hopefully will help everybody kind of think through some of this stuff. And this is kind of comes on my view. Just the title is not quite the same as in the agenda there, because I just want to kind of go over basic approaches to climate change adaptation, and in particular from the engineering side. So a little about me. I don't want to spend too much time, but I've been working on climate change impacts. I've done a lot of modeling, hydrologic modeling, hydraulic modeling, the past several years to look at climate change impacts on hydrology, on stream flow, on stormwater, and ways that we can incorporate climate change, and particularly the uncertainty, which the stuff that Ashley was just talking about, is all relevant. The high levels of uncertainty, and that's the key here. I will want to give folks a heads up, just FYI. So starting in January, I'm taking a leave of absence from Memorial, and I'll be working in industry for a year, just so folks know. I'll still be available, of course, if anybody have questions or anything like that, but just kind of so you know that. So this is just kind of a reminder of our Brace project. That's of course funded by NRCan. I talked a little about this on Monday, but I just wanted to kind of bring it back up. The title of the project officially is Building Sustaining Infrastructure Resilience Through Enhanced Adaptation Training in Newfoundland and Labrador. So the focus has been on training professional engineers, and now we're kind of bringing in a lot of the municipalities to really connect with engineers and give folks an understanding of how they can help engineers do this, because engineers can't do it on their own. They have to work with communities and everybody else to do this. So I want to just do a little bit of clarifying of terms here. So I have here climate resilience and adaptation, and we talk a lot about building climate resilience, and then we throw in adaptation. And so it's important in my view to make clear, and this is not going to make everything completely clear, but at least get some sense of what we're talking about here. So when I think about, well, I'll get to this. In general, resilience is really about how things function and getting services back online, either during some kind of disturbance or quickly after you have an event, and that's really resilient. Everybody has a sense of what that means. And so it's important to keep that in mind. So within engineering, a lot of there's been confusion from what I've seen, that the current in traditional practice in engineering design has been focused on robustness. So this is the ability to withstand a particular event without failure or without minimal damage. So this is not resilience, it's robustness. So while it can also be resilient or part of a resilient system, because I always think, resilience, when you think of resilience, you have to think about a system, because, or a network of assets as being resilient, and not one particular asset. And so a lot of the thinking here, I think, has been on assets, and that's fine. But it's important to remember that the assets are part of a network, so my focus, my interest is really stormwater. So it's quite easy to think on a systems level, and for the civil engineering discipline in general, when we think about resilience, these are the levels we think about, but it's always in the context of a system, right? And this is a lot of what we're getting at, and I think in terms of building this capacity for folks in the province, it's good to keep these in mind in terms of our community levels in particular. Organization, of course, matters, but that also can be considered from a government perspective too. And then, of course, there's individual assets keep going the wrong way. And then I want to point out that I see adaptation as part of this process of getting to resilient systems. It's a response. So to be more resilient, we adapt. And so that's kind of how I view this. So quickly, I want to draw this distinction out, and Joel mentioned this on Monday, and I wanted to make it a little bit more clear. There's a few things to unpack here. One, looking at the image on the graph on the right here, we've got here, mitigation is dealing with reducing greenhouse gases, reducing things that contribute to greenhouse gas concentrations, and this is equivalence of CO2. We won't worry about that. So this is a really important thing to work for. And of course, adaptation can be done in combination with mitigation, but they are different things here. And so on the left, you see two graphs. So these on Monday, Joel talked about the RCPs, representative concentration pathways. These are, I forget what they stand for. These are the new ones so the new IPCC report is just come out, and they use different emission scenarios that are just labeled this. The 2.6 is not the worst, is the best case scenario. And right now they're shifting towards the 7.0, which wasn't available for the RCPs. But again, that's a level of detail we don't need to concern ourselves with. The key point here is that even with improvements, so we control emissions with our 2.6 scenario, which is our best case, we're still going to see climate change. This is temperature. It doesn't matter. We're committed to this level of change. So we have to adapt. This is, and of course, the worst case that happens, the more we need to adapt. And I show here again the sea ice, which is of course of extreme importance to our northern communities throughout Canada and in Labrador, of course. And this is, again, we're going to see continuations in sea ice, which I think, just for perspective, these are changes we're going to see for sure. Now, when I'm thinking about adaptation, resilience, design, there's generally two approaches, and they work together. So if you take a top-down approach, we start from our scenarios and we look at our circulation models, which are our climate models, and then they're downscaled, which is what makes these data from these large-scale models available and applicable to the smaller scales. And then we can design for engineering applications and impacts. And a lot of the top-down approach, you could think of it in some ways, this is the kind of approach with new developments or new infrastructure that's not existed before. This works well. But for assessing and doing things with communities and existing infrastructure in particular, got to take a bottom-up approach. And we've already talked about vulnerability assessments is one of the things we do. We still need our models, of course, and need to use the downscaling, but we need to do these probabilities from using the downscale data. And this is really, the engineering domain is really big in that box. But we need to combine, get more folks involved in my view, in this way to design and reduce the vulnerability. So point here is that again, the conceptions of vulnerability and adaptation capacity or adaptive capacity are closely linked. So whenever we think about these terms, we're always trying to look to reduce vulnerability in some way, and then that leads to reductions in risk. And in general, the systems and communities that are more exposed to these climate sensitive hazards are more vulnerable. And then we have a system with more adaptive capacity can be less vulnerable. So the point there is that so if we have communities with same exact types of systems, say, one might be more vulnerable simply because of organizational issues or funding issues. So there are things that come in outside of the state of infrastructure that can improve and increase and change resilience, which I think is important to keep in mind here. So now I just want to also return to this intensity, duration, frequency curve. So this is rainfall. So this is what Joel showed. So these curves, if we look at the black one, we're looking at our 100-year event. That gives us, for engineers design for that event, say a culvert. What is the most rainfall? What is the flood level that comes with this rainfall? And then when we have, with climate change, we're seeing these curves shift up, meaning that we're seeing more rainfall occur in that 24-hour period. So what was a 100-year event or greater than 50 years is now happening much more frequently. And then when we design, engineers need to design for that same event, the 100-year event. We're now looking at a much greater magnitude. And this is one of the key issues. And this, of course, if our infrastructure is designed for less rainfall, but we're seeing this more rainfall, then obviously we're vulnerable. Our infrastructure is vulnerable here. So I just wanted to kind of bring that back out. So the IPCC, so that's the Intergovernmental Panel on Climate Change. It defines adaptation as the adjustment in natural or human systems in response to actual or expected climatic stimuli and their effects. And so it could help moderate harm, and or it could also allow us to exploit good opportunities. So climate change, there will be some positives coming from climate change, and adaptation allows us to be ready to take advantage of those. And the IPCC also distinguishes the 4 kinds, and I'm going to go through these just because I think it's useful. And when we this afternoon, excuse me, after I speak, when we're thinking about engineering solutions, kind of getting in a sense of what one way to think about it. So if we think about anticipatory adaptation, so this means we just build right now to meet our design performance over the project lifetime that includes what we know about climate change now. And that's essentially like using those new IDFs. That's what's being done, is we're using these climate change updated parameters for design, and we're going to use those for our design, anticipating this change in the future. It could be higher financial cost initially, but there's no long-term investment because we're just designing now. And if we think of this, again, stormwater thing in terms of a culvert, if we're designing a culvert, we design, we construct that, providing that includes that additional capacity that for climate change that we've already should, based on our projections. There's planned adaptation approach, where this is to plan a set of upgrades, and there have been large scale projects that do this, and one is the Thames River project in the UK, just as an example. So this allows for the change of infrastructure over time that accounts for the changes. So you could have a little bit more, or I should say maybe less initial investment compared to anticipatory adaptation, but you need to be prepared financially to make the upgrades, because the design is done. Again, if we look at this culvert, we're going to look at maybe 20 years or 10 years in the future, but we're going to allow for expansion. So we're going to say, okay, we're not sure exactly how much it's going to change. We're going to wait till we have more data, but we're going to build in this capacity to put in another culvert when the time comes and we have a better idea of what the climate change we can expect. Autonomous adaptation. So there's 2 forms of this. One is called progressive modification, and apologize for the jargon, but this is just this one here is that we're going to really redesign and reconstruct in response to climate change, right? So our initial design is not going to maybe not be functional, but we're going to redesign prior to a failure. So it's not planned for like the previous approach, but it's expected. We know that these are going to come, so we're waiting for a certain particular time. Once say our levels at our culvert reach some level, that okay, it's getting to the point where we're almost over capacity, we're going to then improve that. So that could be initially cheaper, but it's could cost more in the end, or in the long run. And then our other form of autonomous adaptation is reactive, and this is we're forced into this situation now, right? For a lot, we just it's going to fail. We accept that it fails and repair it. So this keeps things at the same cost levels, but it could lead to lead to other risks and more costs down the road. So this is probably not the best approach, but it is approach and an approach, and a lot of times with limited finances, you can't really do much more than this. So again, not a good approach, but yeah. So when we talk about risk management, risk assessment, that's this is a process we're going through here, and usually when we're looking at adaptation, we're doing it from a risk management perspective, and then we want to do this prior to implementing any response to the climate change impacts. But one of the limitations with this approach is that you need a more or less accurate description of what the climate is going to be. If you want to, so when you do that risk management, you have to have some good sense of what's going to happen, what changes we expect, and that's not always so straightforward, right? So in general, so I'm going to go over the PIEVC protocol quickly, which is one of it's an important engineering approach to risk assessment and risk management, but it's really kind of under the forecast planning type of approach, where we have, we might have a range of forecasts, but we're limited because we're like, this is our uncertainty. We know what we know, but this is where we think we're going, and then we prepare for this type of forecast. However, using scenarios, you can still use a risk assessment, risk management perspective, but it allows you to explore more of that space of the uncertainty, and there's so much more I can say about this, but as I go forward here, I'm gonna lean towards a time of taking a systems approach to planning for infrastructure and adapting in that way. But the scenarios are much like looking at the different emission scenarios, where this is our worst case, this is our best case, and then you can kind of try and plan from there. And so PIEVC, the acronym stands for Public Infrastructure Engineering Vulnerability Committee. The protocol they set up is really, in my view, codified common sense. We define the project, gather data, we do our assessment, and if there's engineering analysis required, we do that, and then we report. And then there's also the possibility for triple bottom line, which deals with sustainability, which we won't get into. But I want to quickly kind of go over this in the context of what we've already done. So we did a lot of this work organizing the community. I shouldn't say we, I should say Fundamental, Ashley and Emma, who did most of the work here in defining what our assessment parameters are. We look at our town, we look at our what infrastructure we have, what times we're looking at. So you kind of know this going in. Then you need to get that data, what infrastructure is there, and how to understand our climate, what our baseline conditions are, what changes we're expecting, some local conditions. So you get as much data as you have. And I think yesterday that came out in a few of the discussions, that you just needed more information to make this decision. And we do the risk analysis, which is, again, and this is kind of what we're getting into today and started talking about yesterday in terms of risk tolerance. What are the responses to infrastructure, and then you got potential for interactions, and then you can, in this framework, consider these cascading events, and so there's a lot of potential in here, and a lot of what we're talking about fits right into this type of analysis. And engineering analysis is something that, if you need more quantitative information, it's what would need to be done. And I think some of this is leaning towards what we're hoping for here is that, well, you might get to the point where you need it, but it's important to know when you may need this, and how to engage engineers in this process. And reporting is reporting. So I only have a few minutes, so I do want to kind of return here quickly. So we've got here, and I wanted to kind of emphasize that the way I see this is about planning with the uncertainty. We always have uncertainty no matter what we're doing when we're talking about the future. Climate change adds more of it. And so we shouldn't, again, in my view, we shouldn't necessarily design, we have data, we're uncertain what to do, we pick one. I don't think we should do it that way. If we know there's uncertainty, we need to design for that uncertainty itself, knowing that what we don't know is really, really important. And this is where looking at scenarios comes in, because we kind of want to avoid conditions like this. And some of you on the call might know where this is from. But how this happens, I don't know. How you get a culvert right next to a big culvert, nonetheless, right next to a home is just not planned, right? I mean, it's haphazard, and this is a lot of what we see when we look at individual assets. So again, I like, from a stormwater perspective, taking a watershed, pardon me, watershed approach, which is the systems approach, looking at the entire watershed is key. Because the flows are determined by the entire watershed. And this is a little bit from a project we did in Baples. So this is our modeled, these are the yellow lines are our representation of our either our pipes or our channels or where the stormwater is flowing, where you can set up a model that shows that, and you go out and of course you see where things are coming out, and this culvert here comes out down in the lower part of the image there. Then when we run the model with all the existing infrastructure for the stormwater system, and we run it with an extreme condition, the light blue shows areas that are flooded, the dark blue shows areas that may be, really seeing a lot of excess or more vulnerable to the large events. So this helps define our vulnerability. And this is a case where we hopefully don't see something like this, but something like this is possible under that initial scenario. These are images from 2017. Some of you may recognize some of these. I can't recall exactly where these are. I know the one on the left with the backhoe going in the drink is the TCH, and that's clearly not resilient. So the approach here, then once we know what's happening in the system, we can go into the system and make changes. And so the important thing here to recognize is that we can make changes upstream. We can look at natural infrastructure. What role do wetlands and forests play? You can also look at how making small changes in your watershed through implementation of green infrastructure, which we maybe we can draw out a little bit during our discussions today in the groups, but using small scale steps can really help manage the potential for large changes. And this kind of shows how, if we were to do that, you get a lot reduction in some of these other areas, but some changes could reach still be bad in other places. But the idea here is to take a larger, not just look at that one culvert, but look at the system and explore lots of different potential solutions, and some smaller, which could be less expensive in my view. So just to conclude here, the key is uncertainty, right? So we don't know exactly what's going to happen. We don't know exactly what's going to happen with climate change. We don't know exactly what's going to happen with the economy. We don't know what's going to happen with development in areas. So and land use change. So there's uncertainty that goes beyond just climate change uncertainty, and a lot of that is qualitative. And this again started coming out yesterday. Is it matters how people, individuals, communities, and governments want to deal with this uncertainty. And we need local knowledge. We need perspectives from folks who are living with the infrastructure and that makes, who experience this. And my view is to push process. The PIEVC is a good process to follow. We will not be able to follow all the details, but as long as we follow a good process, we should be in a good place to deal with this as best we can. And it is also, I think, more optimistic note is that this with uncertainty gives you that chance to do things right. And again, there's a lot more to unpack there too. But I really think that this is an opportunity now that we have to build, to use the term "build back better," right? To do things better than we have. So that's hopefully useful to you all in terms of thinking about this. This is a lot about how approaches to this, and hopefully this will help frame folks for the afternoon. So I'm going to stop there and turn it over to Emma?
Sure. So Jeff, how are we doing the breakout room arrangement? If we're ready to go, we will be sent off again. Yeah, it looks good. Cool.
All right. I think everyone got kicked back to the main room, whether they liked it or not.
Our groups got smaller today.
We did, yes. So we'll do the sort of group share exercise when we come back. Emma, Who's group one today? Oh, Kathleen. Kathleen, you want to go first? You're muted.
Yeah, I always forget that whenever we change systems. Right back. We were a small but mighty team, split between folks with engineering backgrounds and two council representatives, mayor and a councillor. So that was absolutely fabulous. So we actually moved a little more slowly, but we got through 2 iterations of the vulnerability discussion on engineering solutions. We focused on, of course, the bridge washouts and things like that in zone 1. And as it worked out, Paul, the mayor from Spaniards Bay in our team, they actually had that happen to them. So we spent a fair bit of time actually discussing, the real life implications of that. It was the big takeaways that I think our group wanted to sort of put out there were how much more reliant the communities recognize they are now on these engineering solutions. And so a lot of this stuff around being able to talk to engineers and make sure that relationship is a constructive one is just that much more important. And, next to that, the conversation around asset management that we were just having as, being a really key part of what it is that both ensures that a community has a lot of the data needed in order to be able to enter into some of these more evidence-based decision-making conversations. It really has changed the way they approach things. And maybe I'll throw to Paul, because poor Paul got cut off as he was in the midst of making this particular point. So Paul, are you interested in unmuting and finishing your thought?
To figure out a way to unmute.
Yeah, you're unmuted now. Go for it.
Okay, thank you very much. Like I was saying, this is my third stint on council. So when I first got involved with it 9 years ago, asset management wasn't much of a discussion at the council table, but it has grown over the years as the climate change incidence has impacted our town greatly. Like I said, we've had a major bridge washout. We're having storm surges. Our breakwaters are being tested to the limit, and we've been having a lot of overland flooding. And it sort of points to the importance of having an asset management plan in place, keeping it up to date, and knowing where your weaknesses are so you can plan for improvements as we go forward. Engineering is becoming a lot more of the discussion on a way to move forward. And of course, for financing all of these additional and larger projects are becoming a real strain on small communities.
Fabulous. Thank you. And I think we'll leave it there.
Yeah.
Okay, I can go as the second breakout room number 2. We actually had a very active conversations. All the participants actively participate in the discussions around different topics. So we did a quick recap on yesterday's session. So we wanted to actually recall the vulnerability issues first. And specifically, we talked about Zone 1, causeway or coastal erosion. And through the discussions, we tried to develop a kind of understanding of risk tolerance. So what is the risk tolerance? What's part of risk? What's the role of risk tolerance in decision-making process? And we conversations led to incorporating other lenses into the decision-making table. So from different lenses. I mean, we talk about the role of engineering and how engineering can benefit, and if the engineering is the only solution or not. So we covered these areas, and yeah, I mean, it was an active conversation and pretty much in detail. So it was a kind of a quality conversation over quantity. I'm not sure if anyone else from our group want to add any more comments to my comments or not, but this is pretty much my update of the conversation. So I can leave it here.
So if no one else from the Paris group is going to speak, I'll just talk in our group. We had a small group, good conversation, but I just want to kind of first of all, I want to close my blinds because the sun is giving me stripes. Pardon me for that. Perfect timing. The only time the sun comes out in St. John's is when I'm speaking. I just want to tell you what I got out of this, and I'll leave it open for other folks if they want to contribute. One is that for looking at solutions, while thinking about engineered solutions versus other solutions, is real. There's also a sense where that line is somewhat arbitrary. That so many of the solutions require a gamut, not just engineering solutions. The other thing is that when it comes to looking at engineering solutions, it's clear that there needs to be a bigger move towards nature-based natural infrastructure and approaches that are green, so for lack of a better word, than traditional approaches. So in so many cases, there might only be engineering solutions, but those solutions can be better than they've been, is kind of a key thing. So I'll say, leave it to Julia, Samantha, or Annette if you want anything to add, but that's kind of what I got out of that myself. So.
I think just to tie into that from what Joe was saying, that some of those green infrastructure solutions also might serve multiple purposes. So we said, well, it might be a detention pond, but it might be a detention swale that also functions as a park space. And, so it's not just, so whatever the solution is, you come up with a solution in a collaborative way with the different professions or even community input, but the result is also that they have multiple benefits, not just one, not just preventing the flooding or something, but they have multiple benefits. Yeah, so collaborative solutions. And the other thing we said is, I like what Joe was saying, think upstream. So don't just focus on the it's your breakwater, or it's that flooding situation coming down from zone 4 into the river. But what happens upstream? Like so you think in the broader system versus just engineering one solution to one particular problem. Okay, over and out.
Nobody else wants to speak on that. I think I can go for breakout group 4, not zone 4. Sorry, guys. But I think, well, we were also a small group and we talked a lot about all the, different engineering solutions and community aspects of it. And one of the main, I think, takeaways that we had was having to prioritize where the community wants to spend the money and exactly like how much money they have to spend. So that was like a recurring theme. And then we also did have a question come up, and if anybody kind of has an answer for it, please go ahead. It was that of if there is any policy to create green spaces when for new developments. So that was kind of another question and theme that came up. Yeah, so if anybody else about the group wants to speak, otherwise, this was the main thing, and it was a very constructive conversation that we had. And thank you.
Okay, so I can go for room 5. We were also small but mighty. And everybody, including myself in the group, like comes from a technical background. So the hat they're currently wearing in their position, one was municipal and one was utility based, but both like engineering backgrounds. And so we departed slightly from like what was sort of initially planned as the exercise, because we were all sort of fairly familiar with that process, and then started to talk about like once you sort of have identified what possible projects could be undertaken or what might be solutions to the vulnerabilities you're facing, like where you get stuck in the process of implementation. And so we were talking a lot about the psychology of decision making within the context of discomfort, and how I mean, precarious that can be depending on sort of where you sit in an organization, if you're an elected official versus a staff person in a municipal context versus a non-municipal context. And that a lot of the sort of, oh, sorry, I was coughing in the background there. Like a lot of the change that we're sort of looking at is very emotional, and that those are often like the bigger obstacles to overcome than actually determining what a technical like solution might look like, or how that might happen, or what that might cost, or so it's not like for folks who have a fair amount of practice like determining what direction maybe needs to be gone in. The step then becomes like within the constraint of a regular environment, or according to engineering standards, or within the context of a municipal like legislation context, to like how you would deliver those things. So I thought it was a really good quality and interesting discussion of the sort of non-technical side of delivering technical solutions. So I don't know, Brian or Phil, if you wanted to speak up at all, you're very welcome to.
I think you covered it, Ashley.
Yeah, ditto.
Fabulous, guys, thanks.
Cool, and I'm last this time. So a lot of similar things, of course, were coming up. We had a few more people actually. And what I noticed pretty quick was a lot of the stickies that I was seeing were like the minds were going more directly to more planning type solutions. So we kind of had to re-steer ourselves toward an engineering solution, but often came to the conclusion that, well, you'd need both of them. And I think that'll come back around tomorrow as well. For example, let me get one maybe. Yeah, like the fact that you can plan for a certain, you'll pick up risk tolerance and make some infrastructure changes for the causeway, for example, but there's always going to be that chance anyway that something will happen, and you'll still need a plan alongside whatever you've done to address that physically. Another one thing that came up, Joe and Julia were talking about, and it came up with us too, is the stacking of function and the ability to address multiple things. One cool idea we got was, well, if you put some stormwater retention ponds in like zone 4.3 area, we also know that zone 4 has the fire risk, and right now doesn't have a great water supply. So perhaps you can use some stormwater retention ponds, gather some water that could maybe be used to help out in a fire situation. And then if the fire situation happens, you have some trees that are now not doing their job as well. More runoff is happening, but you're collecting it. So it kind of manages it from multiple directions at once. So that was something cool that I noticed. Anyone from my group have anything to add to that? Cool. Well, we are pretty much on time here, I think, for concluding today. Anything anyone else wants to add in general from across any room?
I'll, if I may, one of the things that I said that I kind of want to share with everybody here at the end was that what from the municipal perspective, decision makers' perspectives, I think it's important that folks know that they can, kind of make it clear to engineers coming in what they want, knowing that there's nature-based solutions. I think too often what happens is that, firm is hired, the solutions that are put in there are standard solutions that have been used in engineering with stormwater, for instance, quite a bit, but that may not be what works for the town, especially when you want to increase use, have multiple uses of the same thing, and use more green infrastructure. But in RFPs, whatever, the municipalities can really make sure engineers do what they want, and that's kind of a big point, I think, and one of the reasons why we're doing this is so that you feel comfortable asking for these things. So that's my bit.
Perfect. Thanks, Joe. I think that concludes it all quite well. And we hope this was enjoyable enough and that you'll come back with us tomorrow for the last workshopping day. Friday is less required of you. You can sit back and just type us some questions if you like. Yeah, so it'll be more chill Friday. But if any questions come up between now and then, send them along and we'll try to address them on Friday, and hope to see you tomorrow. Thank you for your time.
Thank you, everyone.